Hi, friends. Welcome to the Plain Fun RC channel. I'm your host, Saul, and welcome to the continuing build of our experimental aircraft models, Velocity XL Canard. So we're looking at the actual Canard itself right now. We've gone ahead, we've installed our servos. We're using the high-tech 5087 MH high voltage digital micro. These are the same size as the HS85 servos, but they are in a high voltage format. And you can see our specifications here to get an idea of the torque. It's got some phenomenal torque for such a small servo. Now let's talk about the installation. So what we did is you can see here you have your what are called your barrels, from what I understand, which are the arms that are on the side of the servo to hold it in place. You can see the little arms right there. Those have to be removed in order for it to fit here, and because there's a wing spar here, and so there isn't enough room to fit this servo with the barrels in place. You're going to need to make a little notch in here for the wire, and you're using double back sticky tape to hold it in place. And we're using high-tech 1-inch metal arms. You definitely want to use the longer arms than the stock arms that it comes with, because I was chatting with a gentleman online, and back when the company was in business, they were recommending elevator throws that were greater than what was in the manual, because they were having some difficulty with getting the planes off the ground. Not that they wouldn't fly, just that they needed more throw. Anyway, you can see our configuration is very straightforward, nothing special. We've got a Sullivan 256 clevis on a 256 rod with a snapper keeper in place. So the Canard is done. We're going to shift our focus up to the winglets, getting the servos installed, and more to come. All right, friends, as we continue our update, you can see we're working on putting the servo in the actual servo plate for the rudder. So you can see it there. And let me talk to you about what we're doing so far. So you'll see that we've gone ahead and we have attached our servo blocks as indicated there. And in addition to the servo blocks, what we've also done is gone through and we have put on one of our little connectors here, one of the Dubro quick connectors, and instead of using the socket head screw that it comes with, we're using a simple set screw, a 440 set screw, and then sliding it on. Now we're using the stock servo arms, because one of the things you want to be aware of, if you look carefully, let me see if I can zoom in a little bit, you're looking at the clearance, if you will, the actual clearance between the servo arm itself and the actual plate. You want to make sure there's adequate clearance there, and you can see that there is. And the big thing too is you want to make sure, as we come around this way, that you're going through looking at the arm itself. You can see, as we zoom out just a little bit here, you can see that we have the arm is perpendicular to this part of the actual plate right over here, as you can see, nice and even. And you want to try to get it so that way the servo itself is sitting roughly in the middle of the plate. That's an important thing to keep in mind. All right, friends, we're going to go ahead. We're going to epoxy our blocks in place. One friendly tip, and if you take a look at how the servo is mounted, notice how it's raised. It's not sitting flat on the actual plate itself. So it's a good idea to go ahead and mount the servo directly to the actual blocks themselves before you actually glue them in place. That way you determine it has proper positioning for both the width and the height. And the way I did is I simply took the servo, flipped it upside down, and had it so that way the blocks were sitting flush with the servo while it was resting on the actual table itself. So these things are very important, because proper positioning is extremely important, because you have very little room in which to work. And remember, this plate is going inside the end of the wing, so it's very important to keep that in mind. All right, friends, more to come. All right, friends, as we continue our update here, you can see our servo is attached. And let me show you how it functions. It just pulls outward. And that's all there is to it. Very straightforward. All right, so the right rudder is done. We're going to get this attached to the right wing by screwing this in place. and then we'll go ahead and we'll move on to the left rudder. More to come. Hi friends, as we continue our update here, let me go ahead and show you we've got our rudders done. Let me go ahead and give you an idea of the function. See if you can see it. It's really wonderful. Watch each servo carefully. So let's go left. Let's go right. Let's go left. Let's go right. Bring it a little closer for you. Works great. Very happy with it. Now, I forgot to mention, you might be wondering, well, how is it that I'm able to get one servo to travel one way and one to travel the other without them traveling in opposite directions at the same time? So when you go into your computer radio, you want to be able to set the throws so that way you only have one going in one direction and then zero it out in the opposite direction. So in other words, when I move this stick to the right, notice how the servo for the left, the servo for the left rudder does not move. That's because you want to zero out the travel when you're turning it right. And the exact opposite is true for the right rudder, in that you want to zero it out so when you go left, it doesn't move. So notice how I'm going left and this servo here is not moving at all. Okay, that's the trick. So if you have a Spectrum radio, any radio for that matter, but I'm using Spectrum, you just simply go to your servo setup, travel, and then go ahead and you can set it up so that way you have one going in one direction, one going the other, and to be able to zero it out since the servo only needs to move in one direction. Okay. Now, one more caveat I want to let you know. Obviously, we need a rudder servo to steer the nose gear. So you'll create an extra channel in your on your transmitter, okay? Or if you're using an AS3X, you can program it in there. You want to create an extra channel in the transmitter in the system setup, and you're going to label it rudder. That is not affected by the limitations of the travel that you put in. Because remember, these are to specific channels, to the left rudder and to the right rudder, so that's important. The nice thing about this is that the setup initially called for a servo saver, which would require a spring and everything, because since the servo at the time, when this plane was designed, moved in the opposite direction, they didn't have a way of limiting travel. But now, we don't need to worry about that anymore. We can just go ahead and zero out the travel so they only move in one direction. All right, friends, hope you liked the update. We're going to shift our focus back to the fuselage as we finish our build. More to come. All right, friends, as we continue our update, you can see we've got our winglets attached onto our wing, and it just looks fantastic. They came out really, really well. Very happy with it. They function without any binding, and I got to admit, I was a little skeptical of the way the servo was set up, but it just works really well. And you can see on the other wing right over here, the winglet is also in place on that one as well. And it looks great. All right, we're going to shift our focus to the fuselage, getting our NCAA ducts in place to help ensure that we are going through and providing adequate air to the motor and the ESC. More to come. All right, friends, as we continue our update, let me explain what you're seeing here. You're seeing the NACA air ducts, and these are going to be used to help direct air over the motor and the ESC. And they are clear plastic, as you can see, and we just have to trim off the sides, as we've done over here on the one in the distance, and we're going to do the same thing here and on the long one as well. And let me give you a quick shot of the instructions just to give you a rough idea of what we're going to be doing here. And basically what it is that you have these NACA ducts on the top of the fuselage, and you can see as we move to the fuselage here, you can see the ducts right there. And we have two short ones and one long one. The one in the center is the long one. Now, the reason why we're adding these ducts is that if you take a look at the actual inlet itself, notice how there's a gap between the actual fiberglass and the firewall itself. So therefore, we have to make sure air is able to get from that one part of the fuselage to the actual engine, and that's what these clear pieces are for. So we're going to go ahead, we're going to be installing those in the gap on the ducts. All right, friends, let's go ahead and begin the process, and more to come. All right, friends, as we continue our update of the NACA inlets, the little clear plastic pieces. Anyway, you can see we've got our plastic piece in place. You can see it has a nice fit. What we did is we went ahead and we trimmed the sides here, as you can tell. And if you look very closely, you can see that we also have a little notch right there to help clear some of the fiberglass. That's important because you want a nice fit on the sides, and you want to make sure that it sits nice and flush with the front fiberglass piece, which is right here, just so you know. All right, so what we're going to do is we're going to epoxy that here, and we're going to run some epoxy where it meets the actual fiberglass front piece up here, so we can seal the gap, just like we did right over here on that part. More to come. All right, friends, as we continue our update, you can see we have our NACA clear inlet ducts in place. We're letting that center one dry. That's why the pen's there, to help keep it in place. Came out really well. Not the greatest, not super clean up front. It was difficult getting that gap to close properly on all three. But I'm a little less concerned about appearance and more about functionality, because we've got to keep that motor cool. And that's what matters more than anything. All right, we're going to let this dry, and then more to come. All right, friends, as we continue our update, you can see that we have our cowling in place, and we've gone ahead, we've got a couple screws. Let me show you the placement of the screws, because that's very important. You can see it's just below the wing flange here, the trailing edge of the wing flange, and you can see it's right here. And if let me come down a little bit and pan up, and you can see it in relation to the inlets as far as where it's located. That's important. You want to keep that in mind, because if you go too far this way, you're going to wind up actually going into an area where there's very little wood. So just keep that in mind. And the distance from the actual edge of the cowling to the hole is 30 seconds. And what I recommend is using a drill bit, and just take the drill bit, as you can see here, place it right on the edge, right on the edge of the actual cowling, and then just mark it off right on the very edge of the actual drill bit itself, just so you know. And that gives you a perfect mark. Now, I've got a couple extra holes. We've got an extra hole right here, and we've got one right here, and the same is true for the other side. So what we're going to do, much like I did for the Seagull Models GB, is we're going to go ahead and we are going to insert a couple toothpicks here, and then two on the other side. And what the toothpicks do is when you initially put the cowling on, it gives a proper placement, because one of the things you want to be careful with any model airplane is you don't want to put the cowling on, put the screws in, and find you're not on the hole, because then you could all of a sudden be making a whole new hole, and that just gets to be a problem. So it's much easier if you have some placement markings, I guess you could call them, or placement dowels. And then once those are in place, then you can go ahead and put your screws in. It works perfectly every single time. All right, let's get that done, and more to come. All right, friends, as we continue our update, let's talk about what we've got going on. So previously you saw that I drilled a couple holes here as markers. I've got one here, I've got the one here, I've got the one right there, and of course I've got one over here on the opposite side as well, right there. So what we've done is we've taken a good old little bamboo stick, and we've put it inside the drill, and took a little sandpaper, you can see it right there, and we just spun the drill up to help go through and thin out the actual bamboo stick so we can fit it in the hole. And then we're just going to take a very fine tooth X-Acto blade and we're just going to trim it so it sits nice and flush. Now once again, these act as positioners. So before you put your screws in, you slide the cowl on, they fall into the holes, and that way when you go to put your screws in, you're putting them into the correct holes. So anyway, let's keep on keeping on. More to come. All right, friends, as we continue our update, I know I mentioned a second ago that I put in 4 of those placeholders, but I actually had to remove the 2 here, the one here, and the one here, and I left the 2, the first one here and the one on the exact opposite side. The reason for that is because I couldn't get the cowling off. So having just the 2 placeholders is fine. That allows me to go ahead and be able to locate the holes perfectly, as evidenced by this being the hole right here that the screw goes through. So we're good. All right, so we're going to shift our focus now. We're going to remount the cowling, shift our focus to mounting the engine, and we're going to do that in a whole new video series. More to come.